My name is Bo Hansen, and I've been working over 25 years with CO2 safety. Over the years, I found that there's a huge lack of knowledge about what CO2 is, how it affects man, and therefore we've decided to make this film. CO2 is presently the strongest growing gas in the world application-wise. This because of its special physical properties. Because of this, it's used to dispense beer. It's also used to dispense carbonated soft drinks. Within the refrigeration industry, they're introducing CO2 as the new refrigerant. In swimming pools, to neutralize the effect of chlor, you inject CO2 into the water. In the dry cleaning industry, they use CO2 to clean clothes instead of the dangerous traditional chemicals being used. But at the same time, it's also used in the slaughterhouse to put the animals to sleep. It also has to be remembered that CO2 is invisible, you can't smell it, and it is 1.5 times heavier than air. So you have to be aware it will always accumulate in the lowest areas, building up. In order to understand the effect of CO2 on the human body, you have to know that CO2 has a significant effect on the function of the lungs and the heart. Outside air has around 400 particles per million CO2, or 0.04%. The highest recommended value that you have in conference centers, in airports, schools, is around 1500 ppm, or the equivalent of 0.15% CO2. The hygienic limit value set by OSHA as a PEL, permissible exposure limit, is 5,000 ppm time-weighted average over 8 hours, meaning the average CO2 concentration has to be over 5,000 ppm. Usually, alarm systems have a pre-alarm at 1.5% CO2, enabling service personnel to fix a problem, avoiding having to call the fire department, which otherwise would happen at 3%. And the reason for this is that 4% is the immediate danger to life and health level. If you're exposed to more than 8% of CO2, over time, you will die, become unconscious and die. At slaughterhouses, when they put the animals to sleep, they prefer to use around 21%. In order to understand the danger of having a CO2 leak in a confined space, which is the room that we're in, it can be a whole restaurant or it can be an enclosed room. It doesn't matter. It's all the amount of gas in relationship to the volume of the room. We've made a risk calculator, which you can find on our internet site. Since CO2 is 1.5 times heavier than air and accumulates from the bottom up, we use 2.4 meters or 7 feet 10 inches as a standard height, which means that all we need to know when we're calculating is the risk area in square feet and the amount of pounds of CO2. If we take, for example, to give an analysis, 2 50-pound bottles of CO2, 100 pounds, and we use an area of 2,000 square feet. The concentration that you get in this area will be 5.5%, 1.5% above the immediate danger to life and health. level. If we go up to a bulk tank, meaning around 400 pounds of CO2, you actually get up to over 22% CO2, which is massively bad. I believe it's important to understand and be aware that in accordance to our experience, CO2 leaks are very seldom caused by malfunctioning technical apparatuses. It's usually the human error that causes it. Due to recent accidents and because of the versatility of all the new industrial applications of CO2, it's nice to see all the new safety codes being implemented in the United States. The International Fire Code, IFC 2015, edition section 5307.5.2.2 stipulates that you have to have an instantaneous alarm at 5,000 ppm. I call this a CO2 awareness alert because there really isn't any danger at 5,000 ppm, but it is unnaturally high. So be aware, have some type of an indication, which the legislation says, in the immediate area. And then you have the National Fire Protection Association, NFPA 55, and it's in regards to compressed gases and cryogenic fluids code 2013, edition section 13.2.2, and the Compressed Gas Association, CGA G-6.5 2013, standard for small stationary insulated carbon dioxide supply systems, section 3.6. Please note, CGA is not a regulatory body, but 5,000 ppm time-weighted average is a PEL limit, as well as short-term exposure limit, 3% or 30,000 ppm CO2. National Board Inspection Code, the NBIC, Part 1, Supplement 3, installation of liquid carbon dioxide storage vessel sections S 3.4 and 3.5 stipulate half of STEL, which means 1.5%, and STEL 3% as alarm levels for the CO2 alarm systems. In order to summarize the safety codes, unless you want to rebuild the ventilation system, you need a CO2 alarm that has 4 alarm levels. 1, 5,000 ppm instantaneous, where the alarm is made in the area of the CO2 leak. 2, PEL, 5,000 ppm time-weighted average. You need 1.5%, and you need 3% STEL, short-term exposure limit, where you have to evacuate the area and call the fire department. When talking about CO2 safety codes, I often find a negative reaction from the industry, adding costs to an already difficult situation. I'd like to say that I find it actually being the opposite situation. Not only do you avoid terrible possibilities of accidents, but you can also avoid very costly over time sneak leaks of CO2. They're not directly dangerous, but they lead to a higher consumption of CO2, plus a loss of revenue whenever you run out of CO2. With the introduction of new, modern, cost-effective CO2 safety system, costing only a fraction of what they did 20 years ago, not only do they become a lifesaver, but they become a cost saver. Now we're going to talk about the installation. For a CO2 safety system to function correctly, there are some basic rules that have to be followed. Number 1, the sensor must not be mounted more than 12 inches from the lowest part of the floor. Number 2, the warning lamp has to be able to be seen by everybody. The sign next to it has to be mounted in a permanent fashion so that it doesn't fall down. I've seen that way too often, people taping up the signage. Number 3, people ask, how big an area does your CO2 monitor cover? I say, well, it covers the area where it's in. So maximum 15 feet from the distribution point. What's a distribution point? It can be a bulk tank. It can be high pressure cylinders. It can be a dispenser. If you have the sensor and distribution point at the end of a corridor with a horn strobe mounted on top of it, remember, you also have to place another horn strobe before you enter into the corridor with the proper signage mounted in a permanent fashion. If you have your distribution point in a basement with the sensor and the horn strobe mounted next to it, remember, you also have to have a horn strobe mounted before you go down into the basement. This way, you are aware if it's safe or not. Remember, if you have your CO2 bottles inside a room with a CO2 monitor that has multiple entry points, each entrance point has to have a horn strobe above the door. If you're also mounting a central unit, we recommend that you always place it in the manager's office. That way, everyone knows where to find it. And remember, the display on the central unit makes this invisible gas visible. I sincerely hope that this presentation has given you a better understanding of carbon dioxide, its applications, the safety codes involved, the CO2 safety systems, the benefits of them, their installation, and that it will contribute in making life safer for our kids and our loved ones, the people working with CO2 on a daily basis, the firemen that are called upon whenever there's an issue. So, thank you and be safe.